This video is going to work through the final two problems on our normal distribution assignment. Hopefully by this point you're feeling pretty confident, but just in case you want to double check that you did everything right and are approaching the problems correctly, take a watch. So the first question, we are told that the mean cholesterol level in children is 175 milligrams per deciliter, I think, or something, with a standard deviation of 35. And so we're assuming we have a normal distribution going on here. So at this point, we should be pretty confident with this. We stick our mean right in the middle. And so 175. And then I'm going to add and subtract our standard deviation. So plus 35 gives me 210. We're going to add another 35 to get 245. And then a final 35 to get 280. Then we will subtract to go below our mean. So 70 would be the low end at 3 standard deviations away. 105 is 2 standard deviations, and 140 is 1. And this is cholesterol level in children. And the unit is milligrams per deciliter. All right, so we have our normal distribution curve, and we are asked if a child had a cholesterol level of 110, would that data point be considered an outlier? Well, 110 would fall somewhere in here, probably about here. That would be about 110. And so notice that is within our 2 standard deviations. So, here and here and everything in between would be considered normal. So we would say, would it be considered an outlier? No, 110 would not be an outlier because it is within 2 standard deviations of the mean cholesterol level. All right, and then what percentage of children have cholesterol level below 200 milligrams per deciliter? So we need to go up over to our Desmos graph again. We're going to update our normal curve. So I'll put in 175 as our mean, 35 as our standard deviation, and we want below 200. So we're going to put in 200 for the max. Now I haven't zoomed in on my graph yet, but I like to, just to double check that I'm shading the right spot. So below 200, so turned into a decimal, that becomes 76, or sorry, turned into a percent, 76.2%. All right, last but not least, 2 years of age, sardines inhabiting Japanese waters have a length distribution that is approximately normal, with a median of 20.4 centimeters, a mean of 20.2 centimeters, and a standard deviation of 0.65 centimeters. Create our normal distribution. So again, we just need the mean and our standard deviation. The median is just extra information we don't need. And so this is going to be length of sardines in centimeters, just sort of label. All right, so we start at our 20.2. Oops, I'm typing into the wrong square. 20.2. And just to change things up, what if I start below? Let's do the below side first. So 1 standard deviation below would be 19.55 centimeters. 2 standard deviations below would be 18.9, and 3 standard deviations below would be 18.25. Then I'm going to repeat the process, but on the upper end. So if I add 3 standard deviations from the mean, I'm at 22.15. I'm going to go 2 standard deviations, 21.5, and then 1 standard deviation is 20.85 to give our sort of normal distribution. If you go fishing and catch a sardine that's 22 centimeters long, would this sardine be considered an outlier? Well, 22 centimeters is going to be, pretty much, right around there, maybe a little closer to the 22.15. So that's between 2 and 3 standard deviations away. And so, yes, 22 centimeters is an outlier because it is more than 2 standard deviations from the mean. All right, what percentage of these sardines are between 19 and 21? So let's fix up our normal distribution here. So we got to put in our mean, 20.2, and enter our standard deviation. And then we're going between 19 and 21. And I have 85.8%. All right, a fishing advertisement claims that 75% of the sardines they catch are longer than 20 centimeters. Sean looks at this ad and states it's incorrect, and he wants to fix the advertisement. Rewrite the advertisement so that it gives correct information in 2 different ways. Well, one of them is to figure out, 75% of sardines are longer, and we can figure out the length. And the other way is to figure out the correct percent that is longer than 20 centimeters. So there's sort of 2 different ways to approach this. So I'm going to start with the easier way. The easier way is to figure out the percent where they're longer than 20. So what I'm going to do here is I'm going to put 20 in as my min. And you'll notice it's about 62% of the sardines. So they over exaggerated. Now, I want to figure out what percentage would get me 75. Now, if you remember, the mean, I should change colors so that we can, the mean here, there's 50% is above that. Now, between the mean and the first standard deviation is 34% of the data, which means above 19.55 would be 84% of our data points. So 75 is less than that, so I know it needs to be below or above 19.55, but below 20.2. And so, let's try some numbers. Well, if I start with 19.55 just to see, okay, 84%. So what if I do 19.6? I'm at 82, and I'm just sort of trying out numbers. Ooh, I'm a little closer. I'm at 77% here. Now, if I switch to 19.6, I'm at, oops, wait, I went the wrong way. 8. I'm at 73. Now, oops, I went down. 19.7 is 77. So it's somewhere between 19.7 centimeters and 19.8 centimeters. So what if I did 7.5? Ooh, look how close I am. I'm at 75.5. That would technically round up to 76. So, you sort of play with numbers. Oops. Oh, perfect. Look at that. Longer than 19.76 centimeters. And, as I said, there's a range, somewhere between 19.7 and 19.8 would be acceptable. But, I tried to get as close as possible, and it was a little bit of a working backwards. So, I had to figure out what length would get me the percent I'm looking for. And I did go back sort of to that empirical rule to get a general sense of which 2 values I needed to be between, and then I did a little bit of guessing and checking. There are some videos on Canvas if you're curious about the specific formula you could use within Desmos to actually calculate this exactly. I'm not going to go into that here. It's not really a skill that you have to use. It's a sort of nice to know, not a need to know. Hopefully, we're feeling great about normal distributions as a way to sort of analyze data and make some conclusions about it. And, go through and finish your reflections.